Okay, so today I'm going to explain our milestone 2 of our DevOps project, which had primarily dealt with fuzzing and test cases related to that. So I'm going to go ahead and run our main playbook, which goes ahead and sets everything up. We did set up our Jenkins server to be an AWS EC2 instance. So if you try to do this yourself, you will need to set one up and get the private key, and then update the inventory accordingly. But otherwise, I'm just going to go ahead and run this. So essentially, we have a bunch of different playbooks that run various things. So like the first one installs the app packages we need, make sure they're updated. We also clone the repos that we need for our Jenkins jobs, and then install Jenkins, MySQL, Mongo, etc. And you can see these kind of as they run through. So I'm going to let this run for a little bit, and I'm going to check out the README while that runs. So the README does tell you how to set up, similar to Milestone 1, clone it, change into the server, bake or bake, etc. There's actually a part here that says where you have to create hooks. We have actually incorporated that into our playbook, so it does it automatically for both iTrust and Checkbox. iTrust builds automatically because the fuzzer commits, but Checkbox does not have any automatic commits, so if you want to test that, you have to do it yourself. So, part of the reason we used an AWS instance was that every time we tried to run the Jenkins server on our personal laptops, it would crash because it needed more memory, and we just simply couldn't do that with ours, so it was easier to just have a clean instance with AWS, and we already knew how to do the private-public key pairs from a previous project. So with the fuzzer, and it's installing plugins for Jenkins right now. So with the fuzzer that we created, we didn't use everything that we didn't use all of the suggestions because some of them didn't really make sense for iTrust because it was Java files, not Markdown files. So we swapped less than signs with greater than or vice versa sometimes, and then not equal to and equals swap those vice versa as well as zeros and ones. Sometimes we inserted random characters, but in order to meet the constraint of the files still have to compile, we did have to make some checks for that. So for example, with the less than signs, we wanted to make sure we didn't get anywhere where it was like list, less than integer. So we had checks for that where it's make sure whether it's in an if statement or not to change it so it doesn't not compile. With the automation of that, we have a file called fuzz.yaml that copies the JavaScript fuzzer over to the Jenkins server, runs it, and then for 100 times, and then we have test prioritization after that, another JavaScript file that is run after. So the main thing with that, and probably with a lot of fuzzers, is that it didn't always change that much, especially with iTrust and the way Java is set up. The Java files don't always have all of that, or sometimes the Java file has more comments than actual Java code. So the fuzzer did not always change anything, and I can actually bring up the fuzzer itself. So it was based off the workshop, and we have where we swap things based on a less than, greater than, etc. And then it does actually select a random file from the source code of iTrust. We did just go with the source code and not the test code because that would kind of defeat the purpose of randomly changing to see whether tests still pass or not. So we'll see where this is at. Okay, so this looks like a lot of errors. This is actually the loop where it's fuzzing things. So I'm going to scroll back up a little bit. So after we make the post commit and we write it and the post commit file and make it executable, it goes into a loop where it fuzzes a file, tries to commit it, and then it'll run the hook if it does that. The thing with this is that the fuzzer is random. It has a random chance of actually fuzzing something, and then because, again, not all of the files have a less than sign or have an equal sign, it won't always commit anything. So that's why there's a lot of them that say nothing to commit. But it does say change when they are, and so we have it ignoring errors so that it won't change something every time, but on 100 runs, there should be at least 10%, just because that's one of the percentages we use primarily, but also probably more since there's a lot of things that could be changed. So we will actually go take a look at Jenkins right now, which we have our two multi-branch pipelines, iTrust and Checkbox. We'll go to Checkbox first just because it's a little simpler. So right now we have master says it's failing because that's actually due to the Checkbox analysis that we did. The analysis on that checks whether the methods are too long, or that was a primary one we focused on for failing the build. So we can actually go to the console output and see, if we go all the way to the bottom, that it finds long method is true. So it's telling you that you should change this and split your method up, and then also some other places as well. So otherwise, if you scroll up before, it passes up here. It's just lower in our Jenkins file. We change it to the build to be failing when some of the static analysis is done. So, and this is done on most of the JavaScript files. This could be extended to be a little cleaner in that, like, having an array of the files you actually want to analyze. Right now, we just did each of them individually. So, but the post commit does work for that. Just has to be done manually, and then we will swap over to iTrust. So you can actually see that's building right now, number 93. So we didn't we didn't set up a new machine just because we already had a bunch of builds ready for this. And as you can see, there's a separate branch for the fuzzer itself. So we'll go jump into that. And most of these builds are still passing because, again, the fuzzer tends to not change much. So using the fuzzer that we had in the workshop was actually not ideal for this because, again, Java's set up a lot differently than Markdown. So in the future, we would probably extend this to better fit Java. So with our Jenkins job for iTrust, we added in Jacoco, JUnit, and PMD, kind of like they use for software engineering or the other undergraduate computer science classes. So you can see the trends over here, and if we actually go into a build itself, it'll have the results for those, the tests, etc. You can look at the trends themselves. So with the report, so in the master, it didn't actually run the analysis one because I forgot to ignore errors. So we're going to go ahead and run fuzz.yaml again, so it'll redo that, and I'm actually going to make sure it doesn't loop for 100 times because it already did that, and we don't want it to do that very often. But we will still do an analysis to at least show the output of that and how it reads the tests and prioritizes them. So each time it does this, it does npm install all the packages needed. This is left that way just to make sure that they're updated each time, and you have to fetch, branch, etc. So with our analysis file, it prints out all of the tests by their name, how many passed and how many failed, and then how much time it took to run those. And so it prioritizes them by failed at the top, and then if they all passed, all failed, then it prioritizes whichever one is faster. So as you can see, as I scroll up, the time gets lower, and if we go to the very, very top, the shortest one takes a very small amount of time to run, so it's at the very top. So this does go through by the build number. So if you start with the clean build, you will actually have to go into the analysis and change the, it says branch number, build number should be the variable, but you can change it to 1. We just have it set to 57 because that was our first one that actually had the JUnit, just because of the way we were developing. So I think that is it. I'm just going to make sure that we've covered everything necessary. Yeah, and then as for how these checks help software developers, it can help show, and at least for us, like with iTrust, it seems robust enough that small changes don't break the entire thing, which is good, but it also shows that fuzzing is not really a good metric to test iTrust. Pros and cons to each. Checkbox would probably be more impactful, changing because it's a lot smaller in scale than iTrust, but yeah.